Hi guys, Buildzoid here, and today we're going to be doing an oscilloscope video. It's been quite a while since I've last done one. The scope is currently hooked up to the back of a Gigabyte Z690 Aero D motherboard, so just the back of the CPU socket, one of the multi-layer ceramic capacitors in there. And the reason I'm doing it this way is I obviously can't modify the 12900K to get measurements directly from the CPU. As much as I really would want to do that, it's a review sample 12900K, so I can't exactly do that. And the other reason I'm doing this is because I really wanted to know if there's a big voltage regulation difference between the Z690 Aero D and the Z690 Aorus Master. So far I'm only planning to test Gigabyte motherboards, partially because the thing is I'm assuming that the Gigabyte boards all follow a similar design philosophy, so measuring from the back of the socket shouldn't skew results too much compared to if I was measuring from, say, an Asus board, which, like, some of the Asus boards basically don't have any filtering on the back of the socket, which, if I was taking measurements there, feels like, that might not be very, accurate to make comparisons between, that different designs. And so I'm not going to be comparing anything other than the Gigabyte boards for now, because I just don't have a better way to do the measurements. But the main reason I'm doing this is the Master is sort of the more overclocking focused of the two boards, right? So the Master is supposed to be the overclocking board, and then the Aero D is supposed to be the creator board. But the Aero D, in my opinion, has a much better feature set, mainly in that it has dual X8 PCIe Gen 5 support, whereas the Master has one 16X slot, and that's it. And I'm a big sucker for having more PCIe slots connected directly to the CPU. So obviously, I find the Aero D very interesting because it has more PCIe slots connected directly to the CPU. Then the main question was, like, okay, so if the Aero D is less focused on overclocking, is the voltage regulation worse, right? Because I do kind of care about VRMs to that extent. And so I've hooked up the oscilloscope to the back of the socket of both the Master and the Aero D. I've gathered some data, which basically shows what I suspected, which is that there isn't a difference. At least within the measurement capabilities of my cheap Rigol DS1054Z oscilloscope. It is unlocked to 100 megahertz bandwidth. So, yeah, and it is running with no bandwidth limit right now, right? We're bandwidth limit off. Which, incidentally, the Intel documentation actually recommends that all voltage regulation measurements be performed at 100 megahertz bandwidth. So conveniently enough, that's where my scope maxes out. So, yeah, that's the setup here. But the main problem is the 1054Z is, like, if you look at these measurements down here, these all only go down to 10 millivolts. And so the margin of error is 10 millivolts. And the measurements I have from both the Master and the Aero D are within that margin of error, which really doesn't surprise me because I had the same results with, like, the Gigabyte Z490 boards, where even, like, the cheapest Z490 Gigabyte motherboard was basically getting the same voltage regulation performance as the Z490 Aorus Extreme. Turns out that there's a pretty hard limit. And mind you, those oscilloscope measurements were from the actual CPU itself, not from the back of the socket. So if anything, those measurements were more accurate in terms of representing what the actual CPU is seeing, and less dependent on the board design itself. Because if you're measuring on the motherboard, the thing is the CPU socket basically attenuates any, especially any undershoot that occurs at the CPU. Well, that's going to get blocked by the CPU socket to some extent. Whereas measuring on the back of the motherboard like we're doing here will actually increase how much overshoot we see. Like, the overshoot would not be quite as high at the CPU itself as it is on the on the motherboard itself. But the opposite is also true. We see less undershoot than at the CPU itself. So, yeah. But on the Z490 boards, there wasn't really a difference between even the very cheap Gigabyte boards and the super expensive ones. And since then, the voltage controllers have only been getting better. Gigabyte hasn't drastically changed their approach to VRM design. If anything, they've just ditched the doublers that they used on a lot of their Z490 motherboards, so the transient response should just get better, should just keep improving now. But I already kind of suspected with Z490 they kind of hit the limit of what the CPU socket is capable of, well, doing, right? And with Z690 that seems to still be the case. But anyway, let's take a look at some, transient response stuff. So right now we're just going to start off with 4.8 gigahertz on the CPU and 4.6 gigahertz ring. I do have the E-cores turned off because if you have the E-cores turned on, you can't run that much ring clock. And in the advanced voltage settings, in the VRM settings, I have the LLC completely maxed out. So ultra extreme on Gigabyte motherboards should be the equivalent of 0 V-droop, which means currently there's no way to get DyeSense voltage readings on the Aero D or the Master. So we're going to actually see the voltage rise, and also on the back of the CPU socket, we're going to see the voltage come way up because we're measuring before the socket has resistance. Therefore, if we're therefore as the current draw of the CPU increases, the voltage on the back of the socket is going to be steadily further and further away from what the actual CPU is at. And anyway, so Ultra Extreme LLC, because this is the best one for looking at some really awful voltage regulation performance. Like, Ultra Extreme LLC is, like, you should not be using this. Vcore protection, 400 millivolts, iGPU protection, 400 millivolts, though I'm pretty sure I actually turned the iGPU off. I did. And then for Vcore current protection, that's just completely maxed out. We don't want any kind of throttling. And I did mention that the E-cores are turned off. Also, the CPU is completely locked at 4.8 gigahertz. Everything is very, very static, except for thermal throttling. It can thermal throttle. Not that it will, because I have the thermal limit set to 115 degrees Celsius. I would not recommend that for long-term operation, but this is just for testing. So anyway, let's save and reset. Also, DDR5 5400 Micron memory sticks in there. The reason I'm using the Micron memory sticks is because sometimes the way I set up the system for this kind of testing is not great, and so I don't really want to be using the nice SK Hynix DIMMs that I have in a sketchy test setup. So, yeah. Anyway, as you can see, Windows loading already starts showing some transient loading. That's why the waveform isn't nice and smooth like it was in the BIOS, or more like in the BIOS it was a straight line. And now we start to see some effects from, like, the CPU actually doing work. And as it does work, obviously it pulls varying amounts of currents, which leads to the spiky behavior on the of the voltage. So there we go, capture card. Actually, let's blow this out. Pull this out initially. There we go. Yeah. So capture card is being extremely cooperative as always. I'm gonna pull up hardware info. And I'm just gonna actually just put that off to the side. I'm just gonna scroll down a bit, and so now I'm gonna start small FFTs, and the voltage is gonna come up. You're gonna see that in the average measurement right there. Hasn't really gone up as much as I figured it should, but oh well. So voltage has come up a bit. I actually want to check what the motherboard is reading then. The voltage reading. Oh, the motherboard's reading the same thing, yeah, because the Super I/O voltage reading is from, like, the back of the CPU socket. Also, because of how the oscilloscope is hooked up, this is not going to be 100% comparable. Anyway, yeah, like this measurement, I'm not a fan of this measurement method, but I don't have any better way right now to do this. Anyway, so Prime 95 is running. If I move the mouse around, we get the big spikes from Prime 95 getting interrupted. Also, you'll notice that, actually, they're not really that visible. Let's crank up that intensity. Yeah, so you can see that we have those somewhat regular spikes. Those are actually just Windows doing Windows things. Basically I believe it's 16, well, it depends on what setting Windows is in. So Windows basically has a interrupt system that either runs, the fastest it can go is like 1 millisecond. I feel a sneeze coming on, sorry. Anyway, yeah, so Windows can basically, like, normally it runs a 64 hertz, like, event timer, where it periodically checks what the system is doing. So right now we're at 10 milliseconds per division, and you can see that that's like a 16 millisecond gap between these. So yeah, that's the 64 hertz event timer. That event timer can actually ramp up all the way to 1 kilohertz. So 1 millisecond gaps between the spikes, but we're not seeing that right now. Well, if we zoom in on one of these spikes, and we do a single, you can sort of see a load release overshoot, right? Because here we have Prime 95 running, and Prime 95 is a relatively constant current load. At least in small FFTs, it just pulls a very constant amount of current. Then Windows interrupts Prime 95, so the voltage jumps up because the current draw drops because Prime 95 got interrupted. And then Prime 95 starts running again, so the voltage dips down a bit initially. So anyway, but this is not that bad as when you start moving the mouse around, which we're actually going to put the trigger below the waveform for that. I want to... Yeah, so we're going to try and do this there. So this is way worse, which is what I was aiming to get. So now what we have is sort of the same thing, right? We get that, so Prime 95 doing its thing, big spike up because Prime 95 gets interrupted, but this time it's not just the Windows event timer, it's actually Windows handling user input, which is why this happens when you move the mouse. Then it does some processing on the mouse input, I guess. I think also Prime 95 is still trying to run during this time period right here. And then we get this downward spike right at the end, which is Prime 95 resuming operation, right? And this one's way more drastic than the one we got previously. And this is bad because basically, like, the thing is, we're measuring this on the back of the socket, so this would actually be even, like, this downward spike would be even deeper if we were measuring it at the CPU itself. Basically, if this spike gets low enough, your CPU crashes, which is why you shouldn't use Ultra Extreme LLC because it does things like this. Yeah, and this is true of all motherboards. Like, the absolutely maxed out load line calibration setting is just bad for voltage regulation because the VRM ends up trying to fight what the CPU, what the voltage naturally wants to do, and the VRM is going to lose. It's not really much else to it than that. So anyway, that's Prime 95. The other thing I wanted to show you is that Prime 95 is not necessarily the best stress test, or more like not the most convenient stress test. It is, as far as I can tell, still the heaviest transient loading that you can get, especially if you run Prime 95 and just move the mouse around while it's running. I've not found anything that'll get higher peak to peak or more undershoot than that. But it's not very convenient to sit there running Prime 95 jiggling the mouse, right? So instead, what you might want to consider is something like Y-Cruncher, because if you just run Y-Cruncher, it naturally is very noisy. So I'm not touching the mouse right now, and just because Y-Cruncher uses a lot of memory, it's also AVX accelerated, so it's a very heavy CPU workload, and yeah, on its own, like left to its own devices, it'll very regularly cause major transients on the CPU. So it's a very noisy workload, which makes it great for stress testing. Because obviously, like that's one of the issues with Prime 95 is, especially if you use like Ultra Extreme LLC and test with Prime 95, you won't notice a problem until you move the mouse and then it crashes. And I have other videos where I actually show that exact behavior where it's like, yeah, Prime 95 is running fine, and then you move the mouse and it starts dropping workers. I don't know at what exact voltage level this CPU would start doing that, which is why I'm not trying to show that to you here right now. Because, yeah, maybe if I bumped it up to 4.9, well, no, like, it would take me a while to figure out, like, because you want it to be just, you need to get the voltage just close enough to crashing that it doesn't crash instantly, just from running on its own. But anyway, so Y-Cruncher is a very, very noisy workload. It also doesn't run anywhere near as hot as Prime 95 does, which is kind of nice. But it gets very similar sort of peak-to-peak values and just overall transient loading. So that makes it a really cool stress test, in my opinion. Both in terms of, like, it doesn't run as hot, and in terms of, hey, it actually puts, like, it's a very transient load, which is what you want if you are trying to stress test for 24/7 stability. Anyway, let's take a quick look at LinPack, which unfortunately on 12th gen doesn't really work as well as it did on some of the past Intel CPUs. Actually, I'm not going to use the 10 gig data set. We're going to use the 4 gig data set, mostly because I don't want to sit here waiting for it to load into the memory forever. I mean, we are on DDR5 and it is quite fast, but it's not perfect. Also, Y-Cruncher will crash if your memory is not very stable. So, Yeah, and this is 8 gig LIN pack on a 12th gen CPU. And on 11th gen CPUs, this was actually an extremely noisy workload. On 11th gen, not really. I mean, 12th gen, not really. 10th gen, it was really noisy. I've never taken oscilloscope measurements for 11th gen, actually. So that was misspoke. So 12th gen, LIN pack, like, it is still pretty noisy, but it's not, like, on 10th gen CPUs and like 9th gen and 8th gen CPUs, this would basically just be like, it wouldn't be this. It would be way worse than this. Admittedly, I also didn't measure LIN pack from the back of the socket for 8th and 10th gen, but yeah, either way, like, it was way noisier than this, and so this right here to me is basically a bit of a disappointment. Like, LinPack is still a good like system agent stress test and general CPU stress test. It's a bit heavier than Y-Cruncher in terms of how much it hits like how hot it gets in my experience. So far at least. It might also be just memory settings. Like, Y-Cruncher is, I think, more memory intensive, so Y-Cruncher just might be a bit memory bottlenecked with settings that LinPack is perfectly happy with at this point. Yeah, so LinPack is not great anymore, which is a bit unfortunate. Because, yeah, it's just like it's not loading the CPU in the same way that it used to, which is kind of unfortunate in my opinion. Anyway, so that's the various stress tests. Now let's do this with an LLC that isn't just completely stupid. Because Ultra Extreme, like, as you saw, like, there is massive undershoot on Ultra Extreme. And that's on the back of the socket, right? Like, we're not even seeing the full scope of what is happening at the actual silicon, and it already looks really, really bad with Ultra Extreme LLC. And that's normal. That's just Ultra Extreme LLC for you. You really shouldn't use it. There's, like, as to why Ultra Extreme LLC exists is, like, it's, well, I guess with Cinebench or something you could probably get away with it, but generally speaking, don't use Ultra Extreme LLC. Definitely not for day-to-day operation. Anyway, so we're going to drop all the way down to turbo, and so right now we're at 1.2 volts, so I should need something like 1.27 or 6. 1.26. So, with Turbo LLC, we get a bit of V-droop. Right, so our idle voltage is going to be higher. But idle voltage doesn't really matter, because your CPU is not going to degrade while it's sitting there on the desktop, or while watching a YouTube video. That's just not going to cause a lot of damage to the silicon, because it's not, it's not going to cause a lot of damage to the silicon, because it's not working very hard. So high idle voltage is not really a concern, right? Your temperatures are going to be low because the CPU is not really doing anything. This is also why, like, Ryzen CPUs will quite happily ramp all the way up to like 1.5 volts for single-threaded workloads. And 12th gen, for that matter, actually exhibits similar behavior on auto. So anyway, now we still have those, Windows downward voltage spikes from Windows interrupting, well, actually not idling fully, right? Oops. Wanted to center the time base, there we go. But this is basically CPU idle, Windows checks for if there's anything to do, and then CPU goes back to idle. So we get that little voltage dip, but it's really not that bad. And the main thing is, like, the problem with doing this on the back of the CPU socket is, if you were looking at this on the actual CPU itself, there's a decent chance like this spike would actually be smaller, because that is ramping down as actually this one might not be, because we're still on Turbo LLC. So Turbo LLC doesn't seem to be Turbo isn't completely free of undershoot. So there would be a little bit of undershoot on that, but the thing is the voltage is dipping just because we're not idling anymore. Right, so our voltage will actually drop when we run Prime 95 a little bit. Like, we won't be sitting at 1.25 volts, we should drop down to about 1.24, maybe 1.23. Well, maybe 1.23. So, let's hit small FFTs. And yeah, and you can see how average voltage is down to 1.24 instead of 1.25 that we were getting before. But we no longer have, like, any undershoot from the regular just Windows, interrupt thing. So the Windows event timer is no longer causing any undershoot, which is good for like system stability. And then if I start moving the mouse around, we're going to have to move this a bit. Move the trigger down. So if I move the mouse around, we still get that undershoot, but it's nowhere near as bad as it used to be. Actually, we're going to want to zoom out a bit. This is a bit fiddly to do. Yeah, so I'm going to put it in single. There. So we do still get some undershoot. And obviously, if you keep going to more and more droopy LLCs, that'll clean up more and more. So actually, let's do that. Why not? So I'm just going to restart. And we're going to go all the way down to medium LLC, at which point there's literally no undershoot whatsoever. At least not on the back of the socket. Again, if we were at the CPU, we might still see something. Also, it's worth noting that Prime 95 with the mouse being moved around is kind of the worst case scenario that I've found. I really don't know of any other workload that causes as bad transients, and Turbo LLC or High LLC on like Ycruncher already performs really well, which we will see when we go through the other data I've gathered. So for high, actually, wait, for medium we're going to need another 80 millivolts, really? Like, I want the average voltage to be similar for all of the tests. Otherwise, it's kind of, defeats the purpose. Though, you would still see the difference in the shape of the waveform. It's just the level at which it's occurring would be different, which... Yeah, anyway, so now we're going to go up to 1.35. It's also worth noting with how hard 12th gen CPUs are to cool at full load. I'm not entirely certain that you would necessarily want to run Turbo LLC. Because you're going to, depending on how you're stress testing, you're going to run out of cooling before you run out of voltage headroom. Right? Like, if you're on medium LLC, you might be like, oh, I need to set, 1.4 volts. But 1.4 volts idle is going to be fine. And your load voltage is going to be somewhere below 1.3 volts, because medium does have an awful lot of V-droop. And we're going to zoom out. So actually, now I'm going to be putting the trigger above the waveform, because there's not going to be any undershoot for us to trigger on. At least there shouldn't, in theory. There really shouldn't be. The mouse is... There we go. Capture card finally figured out what to do. So we're just going to run small FFTs, and I nailed it. Yeah, we got 1.24 volts average right off the bat. We're going to zoom out a bit. So, yeah, that's just the Windows event timer doing its thing. If we zoom in on that, it's literally just like Prime 95 is running, then it stops running, and then it goes back to running, and there's no undershoot anywhere. Going to zoom back out on that. And now I'm going to move the mouse around. And actually, I'm going to, scroll it forward a bit. Oh, wait, no, I want to scroll it back. Right, because we're not triggering on the end of the interruption, but on the start of it. So, and I was a bit wrong. There's still a little bit of undershoot. Set that to single. Oh, man. There we go. Oh, yeah, okay, we should have been zoomed out. There. So, Prime 95 running, idle, Windows does its thing handling the mouse input, and then it goes right back to running Prime 95. And basically, there's still a little bit of a dip down here, but compared to Turbo LLC, it's basically not there. Right, and then if we zoom all the way out, our average voltage is comparable as before. So the amount of power the CPU is still pulling is the same, right? Because our average load voltage is the same, but our worst case scenario minimum voltage is a lot better, and so the stability of the system is going to be better. So yeah, and admittedly Prime 95 is the moving the mouse in Prime 95 is the most extreme example I can find for 12th gen. I tried messing around with changing the clock ratio, getting into thermal throttle, which on older CPUs would actually cause really nasty transients whenever they started thermal throttling, because basically the whole chip would stop doing whatever it's doing, change CPU ratios, and then go back to doing whatever it was doing. And And Intel has seemingly managed to really smooth out the transition from one clock ratio to the next, which is kind of neat. So that no longer, like, moving the mouse is more significant than the CPU thermal throttling. So that's neat. Because it used to be that basically if Prime 95 started thermal throttling, it would crash because of the transients due to the thermal throttling rather than because it was actually unstable. Though if it's thermal throttling, you probably shouldn't be running it anyway. So anyway, now we're going to run Ycruncher. And yeah. So now you can sort of, like, it is a very transient workload. But yeah, no undershoot, because the LLC is basically spot on now. Also, while Ycruncher is running, moving the mouse doesn't really achieve anything. Probably because it's not using as much of the CPU. Like, there's probably some CPU resources left unused. So Windows has, space to sort of handle the mouse movement without having to stop a workload that's pulling absolutely stupid amounts of current. Not that Ycruncher pulls, like, it still pulls a lot of current, right? Like, our average voltage is almost as low as it was for Prime 95. But yeah, it does pull slightly less current than, it does pull less current than Prime 95. Though that'll actually also depend on what memory settings you're running, because the main difference with small FFT's Prime 95 basically fits into the L3 cache of the CPU. So that's why it's so insanely ridiculously hot. It's just the CPU never stalls out on memory access. It doesn't stall out on anything ever, except Windows sort of going like, hey, is the system still running? Yeah, with Ycruncher, it's much more memory bound, and so consequently, it doesn't pull quite as much power, unless you had insanely fast RAM, which might be something worth looking at in the future. But for now, I've just been testing with the Micron DIMMs, and those don't really go above 5400. Well, they do, but you'd have to put some effort into it, and, I'm not going to do that for just some oscilloscope testing here. So anyway, that's the voltage regulation stuff I wanted to show you. Now let's take a look at the actual data that I gathered from the Z690 Master and the Aero D. So, here is the data. So, same settings as right now, right? 4.8 gigahertz, 4.4, like 8 plus 0, 4.8 on the P cores, 4.6 on the ring. And so we have data for the master, and this data here is like the process data. So the A2MA stands for average, right? So average voltage to our minimum average voltage. So that's this value right here. And then we have A2MM, which is average to the worst minimum recorded during the run. So maximum undershoot, and this is with the mouse. Ycruncher is without the mouse, because as you saw, moving the mouse around while Ycruncher is running just doesn't really do anything, so there's no point. And the thing that I'm a big fan of here is that the worst case scenario, like the A2MM of Prime 95, is really not that different from the A2MM of Ycruncher, right? Which means Ycruncher is actually like a really nice, good CPU and VRM stress test in a way, right? Because, yeah, there's not this, like, drastic difference between these two results, which for some other tests there is. Like, Cinebench, for example, just doesn't... Cinebench... Actually, you know what? Let's run Cinebench. Because I gotta see this. I don't think we're gonna see anything in Cinebench. Like, Cinebench is... Imagine Prime 90... Like, in terms of how it behaves in terms of current draw, at least on past CPUs, it's like Prime 95 if Prime 95 didn't pull any current. Yeah. So this is why, if you're stress testing your overclock with, like, Cinebench, it might look like Ultra Extreme LLC is actually doing a good job, because Cinebench just doesn't care. It cares a bit more about the mouse input than, say, Ycruncher did, but yeah, overall, very, very easy to run for the CPU, so yeah. It does care a bit more about the mouse input than Ycruncher did, but other than that, it's just like... So this is not going to show any kind of, like, voltage regulation differences, unless the motherboard is extremely bad. But I'm not really aware of any. Well, maybe some of the super cheap ASRock boards would get Cinebench to crash. Maybe, I don't know. I'd have to test that. But really, anything using one of the higher end voltage controllers with anything using the higher end voltage controllers and a 6R PCB really shouldn't have any issues. Admittedly, the Aero D and the Z690 Master are both 8-layer PCBs. But, well, I'm going to be testing the Z690 Aorus Pro with the oscilloscope as well, because that's a 6-layer VRM, and, 6-layer PCB, so if there's... So, I also want to check that there's no difference between that and the Master. Because obviously, if you don't need the extra PCIe slots of the Aero D, then you could just get you could just get the Pro, and you still have the postcode. Though, admittedly, it is worth noting that the Pro does have worse memory overclocking. Because the 6-layer PCB may not affect voltage regulation. It does, however, affect DDR5 memory overclocking. So, yeah. Anyway, back to the data. So, Ultra Extreme LLC is like, well, you shouldn't use it. I would basically stick to Turbo, High, or Medium. And actually, if you're not testing with Prime 95 and then like moving the mouse around. You could actually just, like, if you're just using Y-Cruncher for your stress test, you could actually totally go with, like, Turbo, right? Like, already Turbo is doing a great job. Extreme LLC, it's not, right? Extreme LLC is bad. Ultra Extreme is worse. That's kind of what those are for. But at Turbo, already Y-Cruncher is doing, like, a perfectly good job. The board is already doing a perfectly good job for Y-Cruncher. And that just kind of continues, indefinitely, right? Like, there's a hard limit to how good the voltage regulation can get, and basically a Turbo with Y-Cruncher, we already hit that. With something like Cinebench, you might hit that limit at, like, Extreme or something. Maybe even at Ultra Extreme, Cinebench wouldn't show any issues. But, yeah, anyway, meanwhile, with Prime 95 and moving the mouse around, high and even medium LLC still show some improvement. At the same time, I would like to point out that the margin of error on my oscilloscope is 10 millivolts. So, it's probably, not too much of a difference. Now then, let's compare the Aero D, right? So, for some reason, the Aero D seems to need a little bit more seems to have slightly different load line slopes than the Master, or it's because of how the oscilloscope is hooked up. Because, unfortunately, the sockets on both of these boards aren't exactly the same. And so, yeah, that might be affecting this a little bit, but the CPU temperatures are close enough together, which makes sense because this is literally 10 millivolts. So even if one of these boards was actually 10 millivolts higher, they would still, the power draw of the CPU wouldn't change too much. So the temperatures that the CPU would run at would be the same. So yeah, this is one thing I'm kind of annoyed about. But, yeah, if we look at the average to minimum results, so we have 0.05 and 0.07 versus 0.06 and 0.08, which makes it look like the Aero D might be slightly better. But again, we're measuring on the back of the socket. My oscilloscope has a 10 millivolt error margin. I wouldn't count this as for me, this is functionally the same. Or exactly the same, actually. Like, with the equipment I have and the measuring methodology that I'm using, this is not a this is not a difference, right? Like, I would not call this like, okay, the Aero D is definitely better. This is like, this is the kind of difference where it's like, I wish my equipment was better. That's what this difference is like, I wish my equipment was better. Anyway, then we get Extreme LLC, where we still, see a similar difference, though for some reason the minimum is actually just outside the margin of error, right? That's like the A2MM is just outside the margin of error, as that's like a 20 millivolt difference. But then if you look at the Y-Cruncher results, those are basically identical. Again, still with a slight advantage, but the thing is, I am setting the voltage higher. So it's just like the boards, like, this might actually be slightly droopier Extreme LLC than what we have over there, in which case it would make sense that this would be getting slightly better results. Yeah, so that's kind of the thing, is like, I wouldn't really, like, these small 10 millivolt differences, I wouldn't really consider them significant in any way. Then we get to Turbo LLC, and we still have the same issue of, like, I am running consistently slightly more voltage on the Aero D in order to get the same average voltage, right? Like that's the thing is like I'm going by getting the average voltages to match, because if the average voltages don't match, then you can't do an average to minimum or an average to minimum, comparison really. So yeah, or I guess, well, actually, I guess you could, but well, no, you can't. I'm not sure. Like, I like to have the average voltages the same. Okay, like this is still something that, like, I just wish I wasn't measuring on the back of the socket. That would solve this issue. That would really mostly solve this problem. But yeah, unfortunately, I don't have like a 12700K to sacrifice for that for testing purposes, so can't do that. Anyway, so with Turbo LLC in Prime 95, again we have that sort of 10 millivolt improvement on the Aero, which again I don't consider significant. And then when we look at Y-Cruncher, literally the same. That's kind of what I'd expect. Then on high LLC, we have Y-Cruncher is apparently slightly better on the Aero D. It is worth noting that the Aero D uses a lot more multi-layer ceramic capacitors in its CPU socket cavity than the Master does. The reason, like, the thing is, it would totally make sense to me that for, like, because the thing, like, it depends on what kind of transient load you have. If it's really fast and doesn't need a ton of energy, then the multi-layer ceramics would actually have an advantage over the tantalums that you have in the socket of the Master, potentially. But again, with my equipment, like, these differences are so small and they're well within margin of error that, like I wouldn't necessarily be too surprised if the Aero D was actually ever so slightly better at voltage regulation. But with the test methodology that I have here, I would not, like, I wouldn't say that's the truth, right? Like, I don't, yeah, there. Anyway, yeah, and on high LLC, actually, for Prime 95, we actually see a significant difference, which, yeah, it does really kind of look like the Aero D might be slightly better. At the same time, it's also running different voltages, so it's just like this seems to be a droopier LLC, right? Because if we look at my average voltage, well, the average voltage here is still the same, 1.27, but like the gap between the voltage that I have set in the BIOS and the average voltage is bigger. So the LLC on the Aero D seems to be slightly droopier, which really doesn't make sense to me. I'm pretty sure the boards use the same voltage controllers. I would assume they have the same programming. Then again, depending on how maybe the Master's default LLC is tuned to be a little bit more aggressive because the capacitor's configuration there is actually better, which consequently makes these comparisons, kind of breaks these comparisons a bit. Anyway, and then we get to medium 1.375 versus 1.36 for the set voltages, and we get, again, a 10 millivolt range difference, and then, with low LLC, the Aero D seems to be absolutely incredible on low LLC. At the same time, again, margin of error. So, I wish I had better equipment. I should have bought an oscilloscope instead of a 6900 XT. So, that's what I should have done. Because the oscilloscope would still work, whereas the 6900 XT decided to die randomly. Well, not entirely randomly. It was on LN2, but I didn't do anything weird to it. I have other cards that I've abused way more that work way better, or more like work at all. Anyway, where was I going with this? Right. So my conclusion from all of this data that I've gathered is that at the very least, the Aero D is not worse than the Master, which was my main concern, right? Like, that was the main thing I set out to test, was is the Aero D worse? Because the Aero D is not supposed to be like the overclocking focused motherboard, right? Like, the Aero D is for creative people who need 10 gig LAN and Thunderbolt, which is like a weird version of USB-C. And, yeah, so, whereas the Master is supposed to be like the overclocking focused board, but as far as I can tell, they're basically the same, which is a good thing, because that means you don't have to worry about, if I buy the Aero D, is my overclocking going to be worse? No, it's not, because the voltage regulation is the same. They both use an 8-layer PCB. They both use a daisy chain memory topology. They both have SMT DIMM slot. Like, literally, they're basically, and I think they're even priced similar to each other. The Aero D might even be slightly cheaper. I don't know. The Aero D still hasn't been listed anywhere. Fun fact, the serial number on my Aero D is smaller than the serial number on my Master, and I've had the Master for like several months. I've had the Master way longer than I had the Aero D, and the serial number on the Master is like 10 times bigger than it is on the Aero D. So that board has only entered production, like the Aero D has only entered production very recently. Yeah. In terms of performance, they're comparable, and that's like the main thing I wanted to see is just like, you know, will there be any down? Because I'm basically planning to use the Aero D going forward because I prefer the feature set. And so I was just kind of wondering is like, am I going to be screwing myself on the overclocking capabilities of the 12900K by using the Aero D? And the answer, at least right now, seems to be no. Maybe there might be a slight memory overclocking difference, but I really doubt it. Gigabyte is really consistent about copy-pasting their memory topologies around, which is how like their entire B550 lineup has the same memory overclocking capabilities as all of their X570 boards, because, surprise, surprise, they all use the same trace layout. Yeah, anyway, that's it for the video. Hopefully this was somewhat interesting and informative. In the future, I will also, well, technically, you know, I could also test the Extreme. I don't really see much point in doing that. The Extreme is basically a Master with a couple more tantalums. I don't think it's going to make a difference. The Pro is a 6-layer board, so that deserves to get tested just to see if, like, the PCB has any effect, but, yeah. Oh, and obviously I'm going to be testing the Tachyon once that shows up. I have to test the Tachyon. That's definitely getting tested. The Extreme is the only one that I'm like, I don't really care. Actually, that's an understatement. I really don't care about that board. It's too expensive. It's basically an overpriced version of the Master. Or an overpriced version of the Aero D, depending on how you look at it. The VRM isn't really, at least on paper, it's not significantly better. In practice, I'd be very surprised if it is. But yeah. So in the future, I'll probably be covering also the Pro and the Tachyon. I'm not sure that I'll bother with the Extreme. And that's it for the video. So hopefully it was useful. And thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There is a link to that down in the description below. There's also the AHOC Teespring store where you can pick up shirts, stickers, posters, you know, the usual YouTuber merch. Both Patreon and Teespring help out immensely with running the channel, so it would be much appreciated if you check them out, because it's like how I funded the oscilloscope I have right now. That will hopefully get replaced with something that actually goes down to like 1 millivolt instead of just 10 for these kinds of measurements. Yeah, so that's it for the video. Thanks for watching, and goodbye. And where'd my mouse go? Oh, there it is.